Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. I personally found it a little bit frustrating to read this question, and I think the frustration started here at this part, where I was just thinking, oh man, can't you just tell me what the part of the amount is? Like, why are you being so mysterious, GMAT? Just tell me what it is. But of course, in data sufficiency, there are going to be things that we don't know. Whatever that part is, that part got X% per year, and then I got even more frustrated because I was like, well, but what is X? I have no idea. We can just say X is some positive number. And the rest, so again, annoying, right? What's the rest? I don't know. But the rest got a simple annual interest rate of Y% per year. Again, annoying. I don't know what Y is. So there are so many unknowns. There are already 4 things that I don't know. And I guess the only thing we can say is that this part of this amount plus the rest is 60,000. That we can say. So that, the pink part plus the green part equals 60,000. That's the only thing we can say at this point. Now hang on, maybe there is one more thing we can say. We should be able to say the following. The interest that will be earned on the total $60,000 has to be somewhere inside the range of X% and Y%. Now, it's a bit annoying that I don't know which is bigger, X or Y, so I want to draw my number line and say this side is X, that side is Y. I know that I could compute what percent is $4,080 out of $60,000, but just because I could compute it doesn't mean that I should compute it. And since it's data sufficiency, the actual value that ends up being isn't important. The important thing is that one could find that value if one wanted to. And the other thing that's important is that it has to be this 4,080 divided by 60,000 times 100, because X is in percent form and Y is percent form, so you'd have to give it a factor of 100 to make it in percent form. That number has to be somewhere in this range, on this number line. Note also the double-sided arrow between X and Y, reminding me that I don't know which one is which. Is X the smaller number and Y is the bigger number, or vice versa? I don't know. And I'm going to put for now a placeholder somewhere on that number line. I don't know exactly where that belongs. Maybe I'll put it in some kind of shape there to kind of show it's somewhere in that cloud. I don't know where exactly. But that number would be, whatever, 4,080 multiplied by 100. And there's the percent symbol. And we need a denominator of 60,000, whatever that number is. But technically this would be wrong without the factor of 100, because the X and the Y have a factor of 100 because they were followed by the word percent. So if you're going to follow the letter X with the word percent, you need to compensate. You must have compensated for the word percent somehow. So if you have 3% interest on your bank account, do you call it 0.03 or do you call it 3%? Both are fine, both are correct, but if you're going with the one that is followed with the word percent, then you must have given it a factor of 100 to compensate for the word percent. You can't just add the word percent without compensating for it. Then you'd say, I'm getting 0.03 on my investment. But if you say I get 0.03% on my investment, then your bank is ripping you off. It absolutely would be a point of error. Not in this question, because data sufficiency, but in problem solving, It would be. I think one of the things that makes this question so much harder than the previous question is that there's a lot less free info here. We don't know what the quantities are, the quantities of dollars. We know their sum is 60,000, but we have no idea what the breakdown is to the different quantities. And we also don't know any of the properties other than the final property, right? We know the property of the total, but we don't know the individual properties of the initial investments. We don't know what percent interest each of them had. And in fact, we're trying to find out one of them. That's what the question is asking for. So personally, I'd probably start with statement 1 because it's short. It just gives us that simple equation. And I would read this equation maybe not in the same way that other people would read it. I think a lot of people would read it in the following way. They'd say x equals 3y over 4. But I wouldn't read it that way. Can anyone propose a different way to read that? X is 3/4 of y. Right? And then another way to say that is x is 3/4 as far from 0 as y is, and they're on the same side of 0. I'm just trying to help all of you be more flexible in the way in which you read equations. Now in this case, this is a bit overkill because we already knew that x and y are on the same side of 0 because we're talking about percent interest, so we know they're both positive. I did a bit of overkill here, but I don't want to just solve this question. I want to learn from this question as much as possible. In general, if I see an equation like this, I'm thinking x is 3/4 as far from 0 as y is, and they're both on the same side of 0. How do I know they're both on the same side of 0? If they were on opposite sides of 0, there would be a negative on one of the sides of the equation. What can I do now to my picture thanks to the insight that statement 1 provided? Is there any amendments that I can make to my picture now? So here's the number line for just statement 1 on its own. What do we know? We know that 0 is here, and we also know that right there is the 4080 blah blah blah. There it is. We know exactly where that is, right? Now, we also know x is 3/4 as far from 0 as y is, right? So let's draw that. So green, 3/4 as long as pink. Now check this out. You ready? Here's what I'm going to do. I'm going to expand green a bit. Now, of course, I have to also expand pink a bit because I have to maintain that ratio of 3:4. And did that change the answer to the question? The pink's expansion will be exactly 4/3 as much as the green's expansion in order to maintain that ratio of pink to green. And here I can do it again. Expand the green even more. And as long as I make a similar expansion, and when I say similar, I mean 4/3 as much expansion in pink, then I'm still within the laws of the land of statement 1, and I change the answer again. Notice how the average is now much closer to x than it is to y, but where I started, it was much closer to y than it was to x. But in both cases, y is 4/3 the value of x. They wanted to know the value of x. The value of x is wherever that green ends. And that keeps changing as I play around with the green and pink while maintaining the ratio of 4:3 for those distances. The ratio of the principles is the ratio of blue to yellow. Statement 2 on its own just gives us the ratio of orange to yellow. But what we lose with statement 2 on its own is the knowledge of who's bigger, x or y. All right, the relative order of x and y is lost. And even just from that, I can already say statement 2 is not sufficient on its own. Don't you agree, JD? If I don't know which side is x and which side is y, how can I find the value of x? This is statement 2 on its own.
Maybe the class would benefit if you just put that 10% as known. I think there's only one value of x.
Without the double-sided arrow, we can talk about it, right? Maybe yes, maybe no. But the minute you put the double-sided arrow in there, how can you say that you can find x if you don't even know if x is on the left side or the right side?
I always assumed that y would be to the right of x.
But do you see how many mistakes you're going to be making because of that habit?
So you don't even know x is to or y is to the right of x.
I lose that knowledge if I'm not incorporating statement 1. I don't know the relative order of x and y in the number line. Statement 2 doesn't stand any chance of being sufficient on its own. We don't even have to think about it, as long as we are remembering this double-sided arrow. And you didn't remember it because you made a bad assumption. But it's very dangerous to assume stuff in data sufficiency because It's going to lead to a different answer. Let's say we do know the relative order of x and y. Can you find the value of x here? The thing is that you can zoom in to the orange and yellow and zoom out from the orange and yellow, and all the zooming will lead you to different values of x. And what I mean by that, well, if z is 1, then x is 8. If z is 2, x is 6. So different values of z will lead to different values of x. So even if we did know the relative order of x and y, it still wouldn't be sufficient.
Yes.
And what I'm visualizing in my mind is literally zooming in and out of those orange and yellow distances to convince myself that these could lead to different values of x and y. Because every time I zoom, the values of x and y change because they're going farther away from 10% or closer to 10%, while maintaining that ratio of 2 to 3, orange to yellow. I can still expand and contract the picture. When we combine the statements, what do we know? We have a range on the number line. We know which side is which. We know which side is x and which side is y. And we know within that range where the average sits. The average sits closer to the x side than to the y side by a ratio of 3 to 2. But there's another thing that we know that's really important. On the number line, starting from 0, we know that x is 3/4 as far from 0 as y is. And that's a critical point. That's really, really important. Because if I try to move x to the right on the number line, y would have to move with it. Y would have to move 4/3 as much as x moved. But the problem is that if x and y are moving to the right on the number line, and we know that the arrow is set, the arrow has whatever distance from 0 it has, we can't move the arrow, well then what's happening? X and y are moving to the right, but the arrow is staying in the same place. That's going to change the ratio of the distances on either side of the arrow. We have a ratio of distances on the sides of the arrow that's 2 to 3, but that ratio of 2 to 3 can't remain a ratio of 2 to 3 if I start moving the tick marks of x and y to the right or to the left on the number line. So anytime I try to change the value of x in order to lead myself to a different answer, I realize that actually I can't move x from where it is, because any movement of x would invite a matching movement from y, and that's going to change the ratio of the distances on either side of the arrow. 2a to 3a, for a total of 5a. And if the total there is 5a, then this must be 15a. Now the numbers themselves are not so important because this is data sufficiency. What's important is the concept. Like, I know the ratio of all the distances on my number line right now. What's going to happen if I try to expand or contract, if I try to zoom in or out of the green and pink distances?
Values will change according to the value of a.
And if a is changing, then also the value of x must be changing, because x is 15a away from 0. The minute you tell me that you know the value of this arrow, right? JD earlier asked me to call it 10%. So let's say that that arrow is exactly 10%. If we know that value, we can't change a. Why? Because we know that this arrow is exactly 17a from 0. So we can actually infer a if we know the value of the arrow, because we know that arrow is 17a from 0. So if you divide that value by 17, you get a. And if you know a, then of course you can find x. I guess another way to say it is the following. X is 15/17 as big as 4,080 times 100 over $60,000. So I can find x. Now, if I drew this number line without 0 on it, I would have picked E. And that's why it was so important to read the way that I read it. Statement 1 said x equals 3y over 4. But I didn't read it that way. I read it as x is 3/4 of y, meaning x is 3/4 as far from 0 as y is. And I describe that way of looking at ratios in the book. That a ratio is how many times one distance from 0 fits into the other distance from 0. So it's all about distances from 0. I think that's why a lot of people pick E on this question. It's because they're not incorporating the distances from 0 into what statement 1 is really saying. But the minute you draw a number line that starts all the way from 0, you realize, and by the way, I think it's very hard to do this just by visualizing it in your head. I was able to, but not under exam conditions. I was just relaxing at home and I could see it in my head. But this is the only way that I can think of that's a reasoning-based way to see that the statements together are sufficient. With statement 2 on its own, I had that degree of freedom that allowed me to expand and contract or zoom in and zoom out. I lose that degree of freedom when I get that ratio from statement 1. That's the insight that I had when I combined the statements. Another thing that I think is important is when I solved this question, I never even considered finding out what this value is. I never even thought about finding it. I just said to myself, look, I know what that number is, right? So I know exactly where the arrow sits on the number line. I know exactly the value that it's pointing to. I know exactly how far away from 0 it is. So if I know exactly how far away from 0 it is, and I also know that x is 3/4 as far from 0 as y is, and I also know that this arrow on the number line sits exactly, where exactly it sits between x and y, with a ratio of 2 to 3 there. If I know all of those things, then I've lost all of my degrees of freedom. I don't have any more degrees of freedom. I can't play around with this anymore. This is all now fixed. It's like when you're building, you're about to drive a nail through some 2x4 plank. As long as you haven't pushed the nail in, there's a degree of freedom. There's actually a couple degrees of freedom because you have 3-dimensional ways in which to move that plank. But once the nail is in, well, now you only have 2 dimensions that you can play around with it because you can still twist it. But once you stick another nail in, now you have 0 degrees of freedom because you have 2 nails holding the plank onto whatever it's holding onto. And now you can't move it anymore. So that's kind of how I visualize data sufficiency. With statement 1 on its own, I still had a degree of freedom because I didn't know where the arrow sits between x and y. Is it closer to x? Is it closer to y? I don't know. With statement 2, I had a couple of degrees of freedom on its own because I didn't know which side is x and which side is y. And even if I did know which side is x and which side of y, I don't know where we are relative to 0. So I can just expand or contract the picture, and that would be allowed. I have the freedom to do so. But when I combined the statements, all of those degrees of freedom disappeared because I had 2 nails in my plank. I don't know if that analogy is helpful or not, but that's kind of how I thought about it. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.